Hi, a very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss with you for the topic which I discussed previously, that is installation and interfaces. In interfaces and installation, we have discussed about installation and I have discussed about interfaces which are serial and SPI, serial, UART and SPI in the previous class. In today's class, I am going to conclude this particular topic with a detailed narration of I2C and the different installation things in detail. Let's have a quick view about these particular things which we are going to discuss today. The same things, installation, interfaces and serial SPI was completed. Today we are majorly focusing on I2C and some part of installation procedure which are going to be concluded. What are the pre-measures which has to be taken? And coming to I2C communication, a multi-master serial communication bus. This was I2C for connecting low-speed devices. I2C protocol is having a multi-master architecture, unlike the compared to SPI or compared to SPI. With this particular I2C is going to support multi-master architecture, which means multiple devices can initiate communication on a bus. Here, only one master can control the bus at a time. However, the bus attribution, if multiple masters attempt start communicating simultaneously, this bus arbitration process takes place. Whenever the master of low address or the fast rise time of SDL win control, this is how I2C is going to control the things. Coming to addressing, each I2C device has 7 bits of addressing, which allows multiple devices to share the time of bus. The master sends the device address as a part of communication and start sequence. What the address format was. The address include 7-bit device address, which is used for read and write, addressing schema, which is used for transmitting address for read and write, which stands a SDA line low. And coming to the next factor, which is I2C data transfer, where half duplex protocol, which is going to be transmitted in one direction at a time with start condition, which initiate the communication by pulling the SDA with high level. And coming to address phase, where the master sends 7-bit slave to read or write phase. And data transfer, where the master is going to transmit the data 1 byte at a time within the acknowledgement bit after each byte we are getting. And also stop condition, where it is going to be terminated the communication by releasing the SDA whenever SCL is high. The key points which has to be noted in I2C was, it is suitable for connecting multiple low-speed devices on a shared bus, not high-speed devices. And coming to multi-master capability, flexibility in this system design. And it is also flexible for addressing schemas, which enables communication with specific drivers. And also data transfer, which is used for synchronizing the SCLK clock. These are the key points which we need to be considered whenever we are using this I2C protocol. Right? This is how the data transfer will be done. In coming to the next factor, advantages and disadvantages over UART and SPI. See, I2C versus UART and SPI. I will show you in detail by comparing each individually, I2C versus UART, I2C versus SPI. In this particular screen, you are seeing the I2C versus UART advantages. What are the advantages you are getting over UART? It is going to support multiple devices, multi-master capability. It requires only fewer wires, only 2 wires are good enough. It is requiring building address and objects, whereas it is oftenly pulling up the resistors with simple winding. These are the advantages. Coming to disadvantages, it has low data transfer rate and it is more complex protocol with start and stop conditions, and it is susceptible notice time whenever we are using share reverse. These are the disadvantages compared to UART. Now we will see I2C versus SPI, how the things are, how the advantages are. Have a look. These are the advantages and disadvantages over SPI. I2C, by using the I2C communication, it is going to support multiple devices in a single bus, guys, where we require fewer devices. Instead of 2, we are using 4. And here, simple wiring for addressing schema. These are the advantages which we are getting. And coming to the disadvantages, we are having low data transfer, and with start and stop conditions acknowledgement, we require a little bit more protocols, and it is susceptible to noise rate due to shared bus. The bus is shared, right? So there is a chance of noise. This is how the things are over UART and SPI. And I can conclude with a summary: this simplicity, the wire count and multi-device protocol, and how the choice between this I2C, UART and SPIR depends on your requirement, guys. Whenever you require certain bus transfers, you need to choose this I2C, and you need to choose this SPI, and you need to choose UARE. Now I'll show you the use cases of using this I2C in IoT. And here it is a versatile protocol which is used in IoT applications for connecting multiple devices in a shared bus. Here there are some use cases which I want to show you. Sensor networks which are connected multiple sensors, which deals with multiple sensors like temperature, humidity, light and pressure. Coming to low power consumption, it is going to use only low power compared to the other things. And actuator control, here also it is controlling multiple actuators, which is like LEDs, motors, actuators in a conditional manner. And the power management will also plays a major role in actuator control. Why? Because power manager will place a take care, which is taking care of your battery charging, power distribution, etc. And these are the beautiful things which are displayed. And coming to display interfaces, we are connecting with smart displays, OLED displays, LEDC displays, LCD displays, touchscreen controls, which interfaces are utilized beautifully. And coming to data acquisition systems, we are collecting the data with multiple sources. Whenever you compare with the other scenarios, here the sensors are going to act very good. And compared to data aggregation, combining the data sensors and after the analyzing the data very effectively. And these are the other applications such as RTC, real-time clocks, which are used for timekeeping, EEPROM and memory devices, which are used for storing configured data and parameters, audio codecs, which are used for audio processing. And these are the main key benefits of using these applications, which includes reduce wires, which use multi-device support, which use low power consumption. These three are the key benefits of using this I2C communication. Low power consumption, which is suitable for battery power life; multiple device, which is suitable for enabling multiple devices in a single bus. And here only two wires are used for communication purpose. Simplicity, the major advantage, which is easy to implement and usage purpose. And I will show you the brief narration comparison between these three by comparing with multiple spaces. Data transfer in UART serial, SPI serial, I2C serial. Why? Because all these are for serial communication. Coming to clock, asynchronous, synchronous and synchronous. These two are synchronous and this one is asynchronous. Data rate low, medium to high, low to medium. Number of files 2, 3 to 4, 2 SDL, SCL. Topology point to point, master slave, multi-master. UART point to point, SPI master slave, I2C multi-master. Addressing not required, not required, and in I2C it was required. Complexity low to speed, medium, high speed, and here only medium. And coming to use cases, here we will use communication debugging, and here we use transfer and peripheral, and here we use sensor network and low speed peripherals. This was the comparison of UART SPI in detail. Once have a look for a second. Got it? Right, we'll move to the next thing, which is a concluding topic of this particular section, like key observations, the data transfer, clocking, data rate, and the number of files which are utilized here. All these three protocols are used for transferring the data bit by bit, clocking, data date, and number of files which are connected, which we have seen. Topologies, point-to-point topology, master-slave topology, multi-master architecture topology, which are clearly narrated, addressing complexity. All these things are shown in the concern variation screen. Additionally, I can tell you one thing, that these variations are improves flight specific implementations, and power consumption, noise immunity, distance limitations will play a major role. These are the things which has to be shown to you. Device rate low, high, medium, number of devices 2, multiple, complexity low, medium, wiring simple, moderate, simple, typical uses, difficulty, sensor, low lag. These are the things which has to be seen. And this is the UART receiver, ideal for low speed, simple point-to-point debugging, logging. Examples: connecting a microcontroller to GSP, interfacing a GSM model, sensing sensor data to a gateway. And coming to SPI, ideal for high speed, of data, controlling peripherals ADC to DAC, analog to digital, digital to analog, interfacing with memory devices, applications require precise timing. Examples are driving OLED, communicating with flash memory. These are the examples. Coming to ICT and inter-integrated circuit. I already discussed all these three, so that I am going a little bit fast. Have a look. Connecting multiple low-speed devices on shared networks and sensor networks, power management, address devices. These are ideal for I2C. And the examples are cooling temperature, humidity, light sensor with the help of sensor network, controlling LEDs with other activities, interfacing with real-time clocks. These are the things which are shown, and these are the installation consideration. We need to consider all these factors thoroughly, then only installation was done successfully. Device mounting and placement. We need to place the device properly, and we need to mount the device properly. So with that, we will get a good performance, we will get a good data accuracy, and overall system reliability. Factors to consider was device type and functions. If the sensors optimize data collection, temperature sensor, or whatever the heat resources, actuators to find the location effectively, gateways which should be centralized. These are the factors which should be considered. Environmental constraints, temperature, humidity, dust, dubs, electromagnetic interference. All these things should be considered in environment considerations. And coming to physical constraints, space availability, surface type, weight, load capacity. Have a look, guys. These are the things which we need to consider at the time of installation by basing on factor by factor. When compared to environment, temperature, humidity, dust, electromagnetic. When compared to physical, space availability, surface, weight. Factor by factor I am going. And this is the aesthetics, visibility, integration. Aesthetics which has to be considered. Hidden sensor, visible displays, integration which ensures the blend seamlessly with the environment. Accessibility, maintenance and user interaction plays a major role. Right? Mounting options. Wall mounting will be there, ceiling mounting will be there, pole mounting will be there, surface mounting will be there, and enclosure mounting will be there. These are the 5 different kind of mounting options which are given to you. Wall mounting means suitable for indoor. Ceiling is which is suitable for unobstructed view. Pole mounting which is outdoor applications or elevated positions. Surface mounting like tables, shelves. Enclosing mounting which is used in harsh environments. These are the considerations for mounting options. Placement consideration, sensor placements. We need to place it properly, then only it will avoid any kind of obstructions or interference whenever it should be presented in a specific view. And coming to actuator placement, we need to properly align the things, and we need to verify whether it is clear or not. We need to consider the safety and accessibility, and also the gateway placement, which should be maximize the network coverage and signal strength. And also we need to ensure power supply availability. By carefully considering these factors, I can say you one thing, that it is going to extend the device lifespan and enhance the overall efficiency of your IoT system, guys. This is how the things are. Coming to power supply, there are multiple power supplies, battery power supply, which are primary batteries, secondary batteries, and considerations which has to be done: primary, non-rechargeable, secondary, which are rechargeable, right? These are the types of power supply: line power, AC power, DC power considerations. And these are energy harvesting: solar, thermal, kinetic considerations. I am showing all aspects for your cause. And coming to the factors which are affecting power supply choice: device power supply, operating environment, battery life, safety. These are the cost. These are the factors, reliability, which are going to be used for power supply choice. These are the 6 factors: device power consumption, operation environment, battery life, safety, cost, reliability. These are the factors, guys. And additional consideration: power regulation, power efficiency, battery management, power efficiency. These are the additional considerations which we need to take. Power regulations, which are used for power supply optimally, and power efficiency, to improve the efficiency, energy consumption will be taken care. For batteries, which improves battery life and safety. Power over Ethernet, which improves the throughput of Ethernet cables. With this, the things related to environment, key environmental factors: temperature, humidity, which plays a environmental factors considerations. We need to check the temperature, how much temperature was there, how much range it has to be suitable, how much humidity it should be considerable. All these are environmental. Dust and practical, electromagnetical, vibration and shocks, any kind of things will be altitude, magnetization, mitigation services, enclosures, which are the materials, ventilation, shielding, regular maintenance, all these taken care in the environment. Coming to security and privacy conversion, security, device authentication, data encryption, security boost, firmwares, access controls, all these factors will play a major role in security. We need to authorize a person which should use the data. You need to provide physical security for the devices which are kept for installation purpose. We need to give network security as well as, and firewalls has to be provided. These are the various factors which has to be considered. Coming to privacy consideration, data minimization, data anonymous, consentment, data retention, privacy by design, transparency, all these privacy considerations has to be taken whenever we are collecting the proper information. Data minimization, data anonymous, consent management, data retention, privacy by design, transparency, which has to be considered when it comes to privacy consideration. Specific challenges which are going to face at the time of thing: IoT device vulnerability and data privacy, network security, user education. All these factors will place a major challenges when we are installing these IoT devices in detail. Why? Because IoT device vulnerability, where we are having limited power like memory or potential targets of attack, data privacy, which requires a robust privacy methods, network security, complex and making suitable attacks, user education is a potential risk, right? These are the specific challenges. Mitigation challenges, these are the securities, NSIT, IEC standards, incident report response, user awareness, privacy impact. All these factors has to be considered, guys, at the time of installation these IoT physical devices and endpoints. Then only the things are going to be successful in any kind of IoT system. With this, I can conclude the topics such as this particular Arduino and Raspberry Pi introduction, as well as the installation procedure of these physical devices and endpoints, and the interfaces with UART, serial and asynchronous in this. And coming to SPI and I2C comes under synchronous. Guys, with this I can conclude. We'll meet with some more topics in the next class.
Like, share and subscribe. Hit the bell icon for more updates.